Okay, so this video I will try to talk about something called Chinese remainder theorem, and of course I will have to tell you why we have to learn this theorem. Actually, this is a theorem about a method, okay, a method of solving a system of linear congruence equations. So that's why in the first topic I would talk about the system, and linear congruence equation is exactly the equation we talked about in the last video. But in this current video, we are not just solving one equation, but we're trying to solve a system. That means more than one equation. So I will give you examples, give you definition about those system of linear congruence equations, and then I will show you the Chinese remainder theorem, which, as I said, it's a method. It's a method of solving those system of linear congruence equations. And this Chinese remainder theorem is very important because it's like the I cannot say the only method, but it's a very effective method in solving those systems. So you must learn the method. In particular, you have to understand the method and apply it to some other problems, not just the problem I taught in this video, but actually you can do it for any other system. Okay, and of course there will be many examples and possibly some applications about the Chinese remainder theorem. Okay, so let's just begin with the example. Okay, so as I said, system of linear equation is nothing but just solving more than one linear congruence equation. So let's just do it with example. So let's just consider the following system. Um, for example, we have to solve x equal to congruence to 2 modulo 3 and x congruence to 3 modulo 5. Okay, so that means let me just type it. That means x satisfy the two the two linear congruence equations at the same time. Okay, so you have to solve, you have to find that x, that solution x, which satisfies both equations at the same time. So that means you have to find x which is congruence to 2 modulo 3 and congruence to 3 modulo 5. So that is the difficult problem compared with the last type of problem we have seen in the previous video. Okay, because here you have to solve 2. So how can you guarantee that your solution satisfies not just one equation, but at the same time 2 equations? So that is the more challenging problem if you compare that with the previous problems. So let's just see the method. Okay, so as I said, to find x, to find such x, sorry. Okay, so we first consider two easier problems. So let me just put a quotation. So you may think it's not that easy, but let's see. Okay, okay, A, right? A, congruence to 2 modulo 3 and A. Okay, so I'm using small letter. Okay, A congruence to 0 modulo 5. Okay, and then B is another variable. Okay, and this time B has to be congruence to 0 modulo 3 and B congruence to 3 modulo 5. Okay, so So we first solve two system, okay. Namely, we want to find A and B such that A is congruent to 2 module 3 and is congruent to 0 module 5. So that is a little bit different from the x variable, because for x is congruent to 2 module 3, but x congruent to 3 module 5. So it's not congruent to 0 if you take congruence module 5. On the other hand, we also have to solve another problem, which is for the variable b. Now, this case, b has to be congruent to 0 module 3 and is congruent to 3 module 5. So rather than solving x, now we are solving two more variables, so a and b. Okay. Now, why do we have to solve a and b? So the reason is very easy. So if we can, let me just go down a little bit. So if we can solve a and b, then actually we can take x just equal to a plus b. Then let's see what happened. Now just pretend that you know how to solve a and b. Once you get a and b, then you define your x to be the sum of these two variables. Just take x equal to a plus b. Then if you do that, then if you take the congruence relation, if you take congruence module 3, then what is it? Now, because remember, b, after you take congruence respect to module 3, that becomes 0, right? But on the other hand, for a, because by our choice, a has to be congruent to 2 after you take the congruence module 3. So that equal congruent to 2 module 3. This is exactly the first equation that we need. Remember, we want x has to be congruent to 2 module 3, and now we exactly got this result. So this is the first equation. On the other hand, if we take congruence module 5, you have something very similar, but this case you have 0 plus b, because after you take the congruence, by the definition for a has to be congruent to 0 module 5. So that's why you got, you will get this. And for b, by our choice, it has to be congruent to 3. So we got 3 module 5. And we're done. Because see, this is exactly the requirements on x, because we have to guarantee that x congruent to 2 module 3 and also x congruent to 3 module 5, which you can check exactly what we want. So in other words, once you know how to solve a and b, you solve x automatically. Of course, you have to know that you can take the sum. If you don't know you can take the sum, of course you couldn't solve the original problem. Anyway, so that's the key. To solve the original problem, we break it down into two simpler problems. It's easier problem, as I said. Namely, we solve a and b first. Once we get a and b, we got x. So this is our plan. So once we can get a and b, then we know how to get x. Hence, we can solve x if we know how to get a and b. Now, to find, for example, to find the solution for a. Actually, you see, a and b, they are very similar. Once you understand the method in solving a, you should be able to do it for the case of b. So it tests you whether you understand the method. So actually, you just change the number inside the congruence. And then same method applies on B. Okay, so once you understand the method for A, B is just similar. So let's just try to solve A. Okay, now to find a solution for A, okay, so it is enough to find A such that, now remember, okay, A has to satisfy what? So A has to satisfy these two equations. So A has to be congruent to 2 module 3 and also congruent to 0 module 5. So if you ask me, okay, there are two questions, okay, two equations there, right? So if you ask me which question is easier, of course, the other one is much easier, okay, in the sense that, well, because you require A has to be congruent to 0. So that means A has to be what? Has to be a multiple of 5. No other possibility, right? Otherwise, how can A be, right? So that means we have to find A such that A equal to 5k. Okay. For some integer k. Okay, so once you know that k, of course, you solve the second equation, but you have to guarantee that not just for the second equation, the first equation, you have to guarantee that it's also true. Okay, so that means you have to get the k, okay, A equal to 5k such that, and also, okay, A has to be 5k 5k has to be congruent to 2 module 3. Okay, this is exactly what you need, right? Because now you know A has to be a multiple of 5, so that means it has to be 5 times some k. But on the other hand, in order to satisfy the first equation, that's 5k has to be congruent to 2 module 3. Okay, so now it seems that you're not solving two equations, but you just solve one, because for the second one you already solve it, okay, in the sense that you take A as a multiple of 5. So the second equation just got eliminated. Okay, in other words, now you can just focus on the first equation by taking A equal to 5k. Once you know the value for k, you're done, because you can put it back here. Once you know the value for k, you put it back and then take A equal to 5k, then you're done, right? So now this is our question. So how can you get k which satisfies 5k equal to 2? Well, now you just have one equation, one linear congruence equation, and you can apply the method we did in the previous video. Okay, now you just have to solve k. So now it is enough. Okay, or I should say now it reduce. Reduce to solve k from this equation. Once you know that k, then you can take A just equal to 5k. Well, now you have so many different methods to get that k, because it's just one equation. So of course, you can if you don't like this, okay, if you don't like the 3, okay, you can sort of multiply that by some numbers. For example, if we multiply, so for example, we multiply, okay, so multiply it by 2, okay, then we have 10k congruent to 4 module 3, which gives, because remember 10, this number is congruent to 1 after you take the congruence with respect to 3, because 10 minus 10 minus 1, that is equal to 9, and that is congruent to 0. So that means 10 is congruent to 1 after you take the module 3. So you got k congruent to, actually 4 you can also do it. just change it to congruence 1, right? After you take the congruence factor 3. So we got this relation. So k has to be congruent to 1 modulo 3. So now you just but okay, so you even know more, okay, from the previous video. You know how to solve the equation in a more general way. You can get all the solution. But here, okay, at least we can find one particular solution. So if we take k equal to 1, then it solves the equation, and we can take a equal to 5 times 1 equal to 5. Okay, because this is okay, because when solving a simpler problem, okay, so of course in the final stage, okay, we want to solve the system in the most general way. That means we want to get all the solutions. But as a starting point, okay, we are not in a hurry, okay, so that's why we just have to consider one particular solution. So let's see how we can get one particular solution for a and b. Okay, now we get a equal to 5. Okay, you can check whether this is true or not. You can just check. Okay, a equal to 5, you put it back. Okay, 5 minus 2 is equal to 3, so that's why it's congruent to 0. So 5 is congruent to 2 modulo 3. And of course, because 5 itself is a multiple of 5, so it must congruent to 5. Okay, congruent to 0. So a equal to 5 does solve this problem. Okay, so we got a. Now for b, we can do it similarly. Okay, similarly to get b, okay, we take, now because remember b has to be congruent to 0 modulo 3, so that means b must be a multiple of 3. So let's say b equal to 3n, okay, and we solve, we take b equal to 3n into the second equation. So we have 3, okay, and we solve 3n congruent to 3 modulo